So hello, good day. So today we want to look at this question. So it says a winch at the top of a 12-meter building pulls a pipe at the same length to a vertical position, right? Okay, so the winch pulls the rope at the rate of minus 0.2 meters per second. So find the rate of the vertical change and the rate of the horizontal change, okay, at the end of the pipe when y is equals to 6 meter. Okay, so looking at this question, we see that this is the pipe, okay, and this is the coordinates, the points, the value of x and y. They are at these points. So if you trace this one down here, this is the x axis. You trace this down here, this is the y axis at these points, okay, and this forms two right angle triangles. Okay, this is already 12 meter, the same length as that of the building. Okay, and this is S, and the SDT is also given. If from here to here is X, this is also going to be X, and if from here to here is Y, this is also Y, right? So which means from here to here is going to be 12 minus Y. Okay, so being 12 minus Y, this is Y, this is 12 minus Y. Okay, and then from here we can form equation. So one by Pythagoras theorem we can form an equation with this. Okay, so x squared will be x squared plus 12 minus y squared. Okay, this is Pythagoras theorem for the first triangle, and for the second triangle we can also form a right angle, a Pythagoras theorem. So this is 12, this is x, this is y, which means 12 squared is going to be x squared plus y squared. Okay, so from here now we can do what? We can eliminate any of these two. That is, eliminate using the elimination method of simultaneous equation. Okay, this is 1 and this is 2. We can say 1 minus 2, right? So if we subtract this from this, that will be what? S squared minus 12 squared. Then this minus this, that will be 0. Then this minus this, that what? 12 minus y, everything squared, minus y squared. Okay? So if we can simplify this, that will be s squared minus 144. And that will be, this is going to be what? 12 squared minus 24y. Then plus y squared minus y squared. So this and this can cancel out, right? So from here we have s squared minus 144, 12 minus 24y. Okay, so we can differentiate this, and that was d dt of the one on the left hand side, s squared minus 144, then d dt of 12 minus 24y. Okay, so if we differentiate this is going to be, if we use our chain rule, this is going to be d dt of s squared minus 144 dds. We are going to use chain rule. S squared minus 144 ds dt. Okay, and this is going to be dy of what? 12 minus 24y dy dt. Okay, so that's what we're going to get here. If we differentiate this reference to s, that will be 2s. Differentiation of a constant will be 0. Okay, the s dt. And if we differentiate this one, that's going to be what? Dy of this, that will be minus 24. Right? Minus 24 dy dt. Okay? What are we looking for? We are looking for the y dt, right? So from here, the y dt is going to be what? It's going to be, when this one comes down here, that will be minus 2s all over 24, the s dt. And that will be minus s all over 12. 2 here 1, 2 here 12. Right? The s dt. Okay? is minus s all over 12, the s dt. But what is s? So what is s? You can find s from here, right? S, we know that s squared is going to be x squared, then plus 12 minus y, everything is squared, right? And then from here also, s squared is what? 12 squared minus y squared. So if you put this into this, that means s squared is going to be 12 squared minus y squared, then minus, this is 12 minus y, everything is squared. So the square becomes square root on the other side. If you put this one here, that will be what? Minus 1 over 12. Then this is going to be what? 12 squared minus y squared, then minus 12 minus y squared, okay? Then the s dt. Okay, so we know the value of y because they said when y is equal to 6. Okay, when y is equal to 6, we put y here, and the s dt is minus 0.2. If we put it here, then we are going to get our answer. So using our calculator, we're going to punch this in the calculator and get our answer from there. Okay, so using our calculator, that will be we have this is the s dt is minus 0.2 times this one, that will be 0.2 over 12. Okay, then the square roots, then 12 squared minus y squared, and as y squared, then minus, this is 12 minus y, right? Everything is squared. So this is supposed to be 12 minus y, everything is squared, right? Okay, so by the time we put everything there, press calc, y is equals to 6, put 6 there. Then we are going to get 12 minus 0.2. So, okay, so looking at this is supposed to be plus. Then that will give us plus here. And then by the time we put everything in the bracket, we get 1 all over 5. So 1 all over 5 is the answer. Okay, meters per second. That is for the YDC. So now let's look for the XDT. Okay, so the B part of the question, which is finding, we already find the YDT to be 1 over 5 meters per second. So we need to find the XDT. So to find the XDT, you can still use this expression, the Pythagoras theorem for this one. S squared plus y squared is equals to 12 squared. Okay, we can still use this. So if you differentiate this, that will be d dt of x squared, d dt of y squared, d dt of 12 squared. Okay, so this is going to be d ds of x squared, the x dt using share rule, right? So this is d dy of y squared, the y dt, and the differential of a constant is equals to 0. Okay, so from here, this is going to be 2x, the x dt, and this is going to be 2y, the y dt, equal to 0. Okay, so the x dt from here is going to be, this goes to the other side, that would minus 2y. This comes here, all over 2x, the y dt. So that will be minus y all over x, the y dt. Okay? So from here now, we'll now substitute. What is y? Y is 6. And what is x? What is x? X can be obtained from here too. And that will be square root of 12 squared minus y squared. Right? Minus 6 squared. Okay? The y dt is what? 1 all over 5. By the time we put everything in the calculator, then we are going to have our answer to be minus 6 over 5 square root of 12 squared minus 6 squared. Okay? And that will be minus root 3 all over 15. Okay? Minus root 3 all over 15. Okay, so that's the value of the x dt, meters per second. Okay, so that's it. So those are the values we're asked to find. Okay, thank you.